Assalamu alaikum. My name is Sayyid Ali Murtaza and I am from chemistry department. This is a chemistry presentation. The topic of my presentation is lithium-ion batteries. Moving towards next slide, here are the contents. First of all, we discuss about lithium-ion battery, then specifications, lithium battery, construction, working, state-of-the-art technology, applications, disadvantages, modern technology as alternative. Next, moving toward next slides. What what is lithium-ion battery? A lithium-ion or lithium-ion battery is a type of rechargeable battery which uses the reversible reduction of lithium ions to store energy. It is a predominant battery type used in portable consumer electronics and electric vehicles. It is used nowadays very extensively, such as in hybrid motor cars. Then moving towards next slide. Specifications. Now we will discuss its properties, which are very popular. Lithium-ion batteries are extensively employed as power sources in a wide range of applications, owing to their high energy densities, high Coulombic efficiencies, low self-discharge features, and a range of chemical potentials accessible with diverse electrode designs. Especially the past decade has seen a growing trend towards next generation lithium-ion batteries with high charge capacities or power densities developed for electric vehicles, hybrid electric vehicles, etc. Next slide. What exactly is lithium battery? Lithium is the lightest of metals and it can float on water. The electrochemical properties of lithium are excellent and it is also a highly reactive material. Then moving towards next slide, these properties gives lithium the potential to achieve very high energy and power densities in high density battery applications such as automotive and standby power. Lithium batteries are primary batteries in which lithium metal or lithium compound acts as an anode. A lithium cell can produce voltage from 1.5 volt to about 3 volt based on the types of materials used. And then moving towards next slide. Construction. For a battery to work efficiently, its construction should be good. Four components in a lithium-ion cell, that is anode, cathode, separator, and the non-aqueous electrolyte. Different chemistries are used. The anode is graphite, the cathode is an oxide, and the alternating layers of anode and cathode are separated by a porous polymer separator, which is generally made of polypropylene, polyethylene, or a laminate of PP and PE. In all cases, a critical feature of the separator is a controlled amount and uniform size of porosity in the separator. Here is a diagram of the parts of a lithium-ion battery, and this is our electrolyte, anode, lithium carbon, graphite, lithium ion, lithium metal oxide, cathode, electrolyte, porous separator. The electrolyte consists of an organic solvent and dissolved lithium salt. It provides the media for lithium ion transport. Lithium ions move from the anode to the cathode during discharge and are intercalated into, that is, are inserted onto open spaces in the voids in the cathode. The lithium ions make the reverse journey during charging. The electrolyte consists of an organic solvent and dissolved lithium salt. It provides the media for lithium ion transport. Lithium ions move from the anode to the cathode during discharge and are intercalated into, that is, are inserted into open spaces in the voids in the cathode. The lithium ions make the reverse journey during charging. A lithium-ion battery or battery pack is made from one or more individual cells packaged packaged together with their associated protection electronics. Here, moving towards next slide. Cells are constructed by stacking alternating layers of electrodes, such as in prismatic cells, or by winding long strips of electrodes into a jelly roll configuration typical for cylindrical cells. Here we are moving towards next slide. And here we study how does lithium-ion batteries works. The anode and cathode store the lithium. The electrolyte carries positively charged lithium ions from the anode to the cathode, and vice versa through the separator. The movement of the lithium ions creates free electrons in the anode, which creates a charge at the positive current collector. The electrical current then flows from the current collector through a device being powered, cell phone, computer, etc., to the negative current collector. The separator blocks the flow of electrons inside the battery. Here is the diagram of lithium ion cell. Electrolyte, here is the current collector, then cathode, separator, lithium ions, anode, current collector. Then we are studying about the state of the art lithium-ion battery technology. First, we discuss about the lithium-sulfur battery. As a next-generation battery technology, sulfur is a promising candidate for cathode materials. It offers a very high theoretical capacity of 1675 mAhG1, about 10 times of current transition metal oxides. It has higher abundance than cobalt and nickel in the Earth's crust and is of very low cost. Then we are discussing about the drawbacks of lithium sulfur batteries. They, they suffer from low electrochemical potential versus lithium or lithium plus low electrical conductivity and like other conversion type of electrodes, sulfur suffers from the significant volume expansion of approximately 80%, causing material cracking and detachment from the electrode conductive network. Then we are discussing about lithium air batteries. What are lithium air batteries? The working principle of the lithium O2 battery can be explained by redox reactions between lithium metal and oxygen. Owing to its superior theoretical energy density, approximately 3500 Wh/kg1, lithium air batteries have drawn much attention as an alternative technology to capacity lithium-ion batteries. A schematic cell configuration for the lithium-ion batteries with the following reactions. Here you can see the following reactions of discharge and charge. Then moving towards next slide. Here we are discussing about their applications. First, we discuss the cylindrical cells. Lithium-ion batteries made with multiples of cylindrical cells are finding more and more applications in electronic portable devices. For example, laptop computers, cellular phones, camcorders, etc. This is the reason. Because of their high energy density, low weight, and longer cycle life as compared with traditional nickel cadmium or the newly developed nickel metal hydride cells. For the lithium ion system to be commercially viable, it should have capacity and energy density advantages over nickel metal hydride at reasonably low cost to the user. Among the lithiated oxide cathodes, LiNiO2 is the most competitive with the metal hydride system at a moderate cost. For example, higher capacity than LiMn204 but lower cost than LiCO2. To increase the capacity of lithium-ion batteries, higher specific energy cathode and anode materials must be used. This means LiNiO2 and graphitic carbon. Then we are moving towards next slide. Here's the diagram, and this is labeling by these. First of all, safety vent, cathode lead, PTC separator, anode lead, and there are you can also see the picture of this diagram. Then moving towards next slide. Prismatic cells. What are prismatic cells? The use of small prismatic lithium-ion cells is emerging. Large prismatic cells have also been considered for electric vehicles and military applications such as NSWC DATPS. Prismatic cells have been preferred in applications with moderate current density requirements. In the development of prismatic cells, electrode processing, integrity, and cost assume major importance. With lithium-ion cells, several electrode manufacturing techniques can be used, such as slurry coating, calendering, or extrusion. The success of these processes will depend on the availability of the good binder to adhere the electrode materials to the current collector. Then moving towards the next slide. Here you can see the diagram. You can see that the upper cover, jelly roll, aluminum shell, cathode, separator, anode. Then moving towards next slide. Here we're discussing about their disadvantages. First of all, we discuss the cost. A major lithium-ion battery disadvantages is their cost. Typically, they are around 40% more costly to manufacture than nickel-cadmium cells. This is a major factor when considering their use in mass-produced consumer items, where any additional costs are a major issue. Developing technology, although lithium-ion batteries have been available for many years, it can still be considered an immature technology by some, as it is very much a developing area. This can be a disadvantage in terms of the fact that the technology does not remain constant. However, as new lithium-ion technologies are being developed all the time, it can also be an advantage as better solutions are coming available. Aging. One of the major lithium-ion battery disadvantages for consumer electronics is that lithium-ion batteries suffer from aging. Not only is this time or calendar dependent, but it is also dependent upon the number of charge-discharge cycles that the battery has undergone. Often batteries will only be able to withstand 500 to 1000 charge discharge cycles before their capacity falls. With the development of lithium ion technology, this figure is increasing, but after a while, batteries may need replacing, and this can be an issue if they are embedded in the equipment. Lithium ion batteries also age whether they are in use or not. Despite the usage, there is also a time related element to the reduction in capacity. When a typical consumer lithium cobalt oxide LCO battery or cell needs to be stored. It should be partially charged around 40 to 50% and kept in a cool storage area. Storage under these conditions will help increase the life. Then we are moving towards the next slide. Here we discuss about what are the modern technologies as an alternative. First, we discuss the nanoball lithium tungsten batteries. Working on the battery anode materials, researchers at N1 Technologies include added tungsten and carbon multi-layered nanotubes that bond to the copper anode substrate and build up a web-like nanostructure that forms a huge surface for more ions to attach to during recharge and discharge cycles. That makes recharging the nanoball lithium tungsten battery faster, and it also stores more energy. Zinc manganese oxide batteries. Investigating conventional assumptions, a team based on DOES Pacific Northwest National Laboratory found an unexpected chemical conversion reaction in a zinc manganese oxide battery. If that process can be controlled, it can increase energy density in conventional batteries without increasing cost. That makes the zinc manganese oxide battery a possible alternative to lithium-ion and lead-acid batteries, especially for large-scale energy storage to support the nation's electricity grid. Here are the pictures of these two batteries. You can see the diagram of these two batteries. Thank you. Allah Hafiz.